Hello friends, welcome back to Era. In this session, we will study how to calculate a range for a vehicle which with considering a battery pack in voltage and ampere. In last chapter, we already studied about the parameters of E2O, that is mass, area, coefficient of discharge, then air density, gear ratio, accessories power, transmission efficiency, motor efficiency, regeneration ratio. So in that we have already find out all the parameters in a graph function. So for after that we have to find a particular range of the vehicle. For that I have plot, or we have to plot a SOC versus distance graph. For that, the SOC means the state of charge and the distance which is covered in a particular cycle. So from this we have already calculated the energy required for a battery in kilowatt hour for the particular one cycle. So after how many cycle it is going to discharge, we will find in this tutorial. So let's start. Before that I will one change in it. This is coefficient of drag. Sorry for my mistake. I will please confirm once if you have done that mistake, and please check it. Then we have now let us start with the program. Here is a velocity which we have already put in the last chapter, and I already explained you what is the syntax to call the or import the Excel sheet in a particular script. After that we have put a mass, area, coefficient of drag, then gearing ratio, average power, then voltage, then battery capacity and battery energy of the battery. Also transmission efficiency, there are some losses in it, so we have calculated transmission efficiency and motor efficiency, then the regeneration ratio. After that we have plot this particular points to define it into the matrix format. Then we consider a discharge cycle for one cycle. Then we have to now consider a SOC, means state of charge, which is greater than 20, means when our battery is from 20 to 100, in that point period we only calculate our range for the vehicle. Then for our for loop we have considered the same point as we discussed earlier, that is aerodynamic drag, rolling resistance, hill climb resistance, linear acceleration and the total traction power, means from the total force we have calculated a traction power. After that we have calculated a motor rotational speed. So what is the motor rotational speed? It is the 2 pi n by 60. So if we multiply it by the gear ratio and the tire, then we will get a motor speed of the vehicle. Then we put one condition that when the omega is 0 and our traction power is 0, then our at the end of the output of the motor there is no power considered and no torque. But if we move our vehicle, when a PTE is means traction power is in a cruising mode, we have to calculate our motor power. So the output power is always greater than the shaft power, because in a shaft there are so many losses, that is rotational losses or the some twisting losses, it having some its weight of that material. So we have considered the transmission efficiency as that is 0.95, that is 95%, and the motor efficiency 80%. So according to the various types of motor, we have to choose our efficiency. Then while braking, it is considered that the regeneration efficiency we have to consider at the end of the each cycle. From this we are finding the P motor, that is the output of the motor, and we are dividing it by the omega. So we are collecting the torque from it. But after the collecting a torque from it, we have to find power required from the battery. So what is the power required from the battery? I already explained in a last chapter that power required from the battery is a motor input plus the all the accessories input from the battery, or the accessories which are run by the battery. So energy required from the battery is the previous energy in a last second plus the battery capacity is called as the energy of the battery. So we are getting the graph in a increasing order. Then we have already gives the discharge cycle as a 1, but after some increments we are calculating it for the SOC is greater than 20. So after the increments we are having a discharge cycle for a continuous way. When it goes to the 20, we will having a graph that is SOC versus distance. Then we have energy consumed so far in this cycle. So we have convert this into the kilowatt hour. Then the energy left in the battery, that is energy of the particular cycle of that capacity, is equal to the energy of the battery in kilowatt hour minus energy of the battery in that particular cycle divided by the factors to define it in kilowatt hour. Then the main part is come, that is SOC. SOC is present charge available divided by total charge capacity. So here SOC is energy of the battery consumed minus energy, that is charge available in a battery, and this is the total charge of the battery. Where we have find it? We have find here, that is energy of the battery, that is battery voltage into the battery capacity, that is kilowatt hour. So for this SOC, when the SOC goes beyond the falls to 0, it comes out the loop. So we take here the break command, and after we close the loop. Then after particular cycle, the SOC final is equal to the SOC at that instant. So we have considered this C, where C is noted, this is C is equal to 2 as to n, and n is the length of the velocity, means how much particular time we are doing this particular iteration. So the energy battery in kilowatt hour is equal to energy at the end of the battery, and hence we are going to print the SOC at the end of each cycle, that is SOC final, and the distance total is equal to distance total plus maximum distance. So we also plot the distance travel at the end of each cycle, and we are going to plot the distance total versus SOC graph. So this str means we have to give the naming to the top of the plot. So let's run this program, guys. So we will get some knowledge about this. So here it is what we are print, that we are printing SOC and each of SOC at end of each cycle, that is 95.50, means here 95.50, and the distance traveled by the each cycle is 5 kilometers. So here the 5 kilometer distance traveled by the cycle. Then the after particular cycle, particular iteration, we are going and we are finding that in 20, whenever there is 20% SOC remaining, we have traveled to 129.09 kilometer. So this 0 to 20 is a reserve for the vehicle. So the E2O vehicle is considering a total travel of 140 kilometer in its particular range. So we have validated our range calculation on the MATLAB software. If you have any doubt, please ping us and or send a message to customer or the particular expert, so we can help you in a particular program if there is any problem. Okay friends, so see you in a next week. Thank you for joining this lesson. Thank you.